Today we are doing section 3.9 and section 310. Our objectives today for 3.9, students can find the equation of a linear function, and for 3.10, students can determine if a relation is a function. So first of all, what is a linear function? Right? A linear function is written in the following form: f of x equals mx plus b. Now that should look very familiar, except for the f of x. We are used to seeing that as a y value. Okay? So we would say then that the graph of function f is the line y equal mx plus b. So basically, this is the same as this, except for this first one is function form, and the second one is graphing form or linear form. Okay? Because in both of them, m, or I should say where, m is the slope and b is the y-intercept. So basically we're not doing anything really different except for we replace the y with f of x. So you can go back and forth on these depending on what you want to do. So for example, let's say I want to find a linear function f given the slope of the graph of f is 1/3 and f of 6 equals 0. Well, this is really just a point, because remember, this number is your x value and f of x is really just equal to y. So we have y equals 0. So this is y. So this is really the ordered pair 6, 0. And this is m equal 1/3. And from the previous part of the chapter, we know if we have the slope and we have a point, we can find the equation of the line by using y equals mx plus b. So m is 1/3. This is my x, this is my y, so 0 for y, 6 for x, and I need to find b. So I get 0 is equal to 2 plus b. Subtract 2 from both sides. So then b must equal -2. So the graphing form of the equation of the function is y equals 1/3 x minus 2. But now I want to put it in function form, so all I do is replace the y with f of x. And there we have the linear function whose slope is 1/3 and that goes to the point 6, 0. Alright, so let's call that example 1. Example 2. Find the linear function with m equal -3 and f of 0 equal 12. Okay, so really this is slope is negative 3, and they're giving us the order pair 0, 12. But what do we know when it's this form, 0, 12? Well, when x is 0, we know that that is the y-intercept, which we know is equal to b. So in this case, they're giving us the slope, and they're giving us the b value. So we can use y equal mx plus b, do exactly what we did earlier in the chapter. Replace m with negative 3, replace b with 12. There's the graphing form of the function. Now it's just one extra step. We're going to replace the y value with f of x. And there is our answer. F of x is equal to negative 3x plus 12. That is the linear function where with slope of negative 3 that goes to the point 0, 12. Okay, example 3. Example 3. M equals 4 and f of 2 equals 7. So again, what they're giving us here is the slope, which we have here, and this is really just the point 2, 7, because remember the number in here is an x value, this is a y value. So they're giving us the slope and a point. So just like we did earlier in the chapter, we use y equal mx plus b, plug in what we know. This is x, this is y. So 7 equals 4 times 2 plus b. 7 equals 8 plus b. Subtract 8. And so what we get is b equals negative 1. So the graphing form would be y equals 4x minus 1. Now the last step to turn this into a function, to write it in function form, we replace the y value with f of x. Now remember that we can go back the other way too. If I give you this function and I ask you to graph it, you can replace the f of x with y and go back to that. So it just depends on what it is that you want to do. Okay. Right now we're writing the equation of the function. So last example like this. In this case I have f of 3 equals 12 and f of 5 equals negative 2. And what I want is the equation of the function that takes 3 to 12 and 5 to negative 2. In other words, I'm looking for the rule. So really what they're giving me here is 2. Alright, so we have 3, 12, and we have 5, negative 2. So first thing we have to do is find the slope. So we have 12 minus negative 2 over 3 minus 5, which is 12 plus 2 over 3 minus 5, or 14 over negative 2, which is going to be a negative 7. So our slope is negative 7. Then I'm going to use y equal mx plus b, and I'm going to use the first point. So y is 12, m is negative 7, x is 3, and I want to find b. So I have 12 equals negative 21 plus b. Then I'm going to add 21 to both sides. So I get 33 equals b. So my graphing form is y equals negative 7x plus 33. Now the only thing left to do is put it into function form. F of x is equal to negative 7x plus 33. And again, notice all I did was replace the y with f of x. Okay. Now we want to talk about relations and functions. Okay. So a relation is any set of ordered pairs. Okay, that's a relation. A function is a relation, but it's a special relation where in the ordered pairs every x value is unique. Okay, so for a relation to be a function, so a relation is the bigger set and functions are the more specialized set. For a relation to be a function, every set of ordered pairs has to have a unique x value. So for example, let's say I have the set of ordered pairs 1, 2, 2, 2, 3, 1, and 4, 1. Okay? In this, this is a relation. It's definitely a relation because it's a set of ordered pairs. This relation has a domain of 1, 2, 3, and 4. It has a range, the y values, of 2 and 1. Okay, but the key is, notice that every x value is a different number. So therefore, this relation is also a function. So it's a more specialized one where it's a function. Okay. Example 2. Let's say I have domain is the set of numbers 1, 2, and the range is the set of numbers 3, 4. And we have a rule that takes 1 to 3, 1 to 4, and 2 to 3. In other words, I have the ordered pairs 1, 3, I have the ordered pair 1, 4, and I have the ordered pair 2, 3. Okay, now this is a relation because it's a set of ordered pairs. But notice that this x value and this x value are the same number. And so therefore it is not a function. Okay, so it is definitely not a function. Okay, number 3. Let's say I have this graph. Okay, this is -1, -2, -3. This is 1, 2, and 3. This is 1, 2, 3. Right? And my graph is this graph. Okay. Now remember, oh, I'm sorry. Let's go back to this other one. The domain of this one is 1, 2, and the range, well, I should write this. Let's write this like this. All x such that x equals 1 or 2. And this one is all y such that y is equal to 3 or 4. Okay? Now in this graph, my x values, which are my domain values, run from -2 to 2. So those are my x values. So my domain is all x such that x is between those two numbers. So x is greater than or equal to -2, but less than or equal to 2. The range, remember, are my y values. Well, my y values, the smallest y value I have is here, and then I keep going up forever. Okay? So my range is all y such that y is greater than or equal to 0, because 0 is the smallest y value I have, and then I just keep going up. Now, is this a picture of a function? And no, it is not, because look at here, 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 and here. This is the ordered pair 2, 1. This is the ordered pair 2, 2. This is the ordered pair 2, 3. So this is not a function. Okay? And we can also tell that it's not a function by what's called the vertical line test. And it says a relation is a function if and only if no vertical line intersects the graph more than once. Okay, so for instance, going back to this one here, we can see that if I did a vertical line, let me do a different color. If I did a vertical line right here, it intersects the graph at infinite points, so that's definitely not a function. So if I have the graph of a line, let's say I have a line that goes like that, okay, well that one definitely is a function because it passes the vertical line test. Anywhere I put a vertical line on the graph, it will go through no more than one point. Okay? But let's say I have this graph. Here's my x, here's my y. And let's say I have some graph that looks like this. Does that graph represent a function? And no, it definitely does not, because if I put a vertical line here, it goes to the graph in more than one point, so that it fails the vertical line test, so therefore it is not a function. Right, so if I had something like this, would that one be a function? Okay, well first, does it pass the vertical line test? Is there anywhere on the graph that you could put a vertical line where it would go through more than one point? No. So this is a function. And remember, this one is not a function. So if you have the graph, you can very quickly see whether something is a function or not.